Hi, my name is Vikram Gundeti, and I'm a distinguished engineer at Foursquare. T- Today, I'm going to talk about Foursquare Graph and how it makes it easier for businesses to derive value from geospatial data. I'll start with a brief history of Foursquare, the products we offer, identify some of the challenges in handling geospatial data, and explain with examples how Foursquare Graph addresses this problem. So let's get started. Let me start a bit about the origins of Foursquare. If you have used the mobile apps in 2010s, you must be familiar with Foursquare. It was one of those real world social networking apps which popularized the notion of check ins. Unlike the social networking apps of today, Foursquare incentivized people to move and discover new places, and meet new people. And in enabling those experiences, we built a very nuanced understanding of places in the real world and how people are moving around those places. In the late 2010s, Foursquare pivoted to enterprise and became the invisible location layer of the internet. We are trusted by some of the big brands such as Uber, Snap, Nextdoor, Redfin. If you're using an app that is using location centric experiences, most likely you're using some of the Foursquare products and services. Our product line consists of data products, mobile SDKs, and APIs that allow other app developers to embed location-centric experiences into their apps, and software services related to the advertising domain. We also have a visualization tool called Studio, which allows analysis of large-scale geospatial data um, and derive valuable insights from that. Our entire product suite is built on two foundational primitives: places and movements. Now let's talk a bit about let's talk a bit about the opportunities and challenges with geospatial data, and why is it gaining a lot of momentum lately. So first, what is geospatial data? Geospatial data is any data tied to a location or a geographical segment on it. It could be a building, it could be a place, a weather, traffic, or population. All of these are considered geospatial data. And in the recent years, the amount of information tagged with location is increasing at an astronomical rate. And that's where the geospatial data's prominence is increasing. And I'll talk a bit about like why it is useful, like what are the different applications of geospatial data. When we think about location, typically we think about app-centric experiences, whether you're taking an Uber, you're trying to find a restaurant, or you're trying to find a place to go to while on a trip, and all those things. But there is often less understood use case of geospatial data, which relates to making key investment decisions in businesses. For instance, you're trying to plan a new store. You want to have awareness of the neighborhood or the mall in which you want to put up that store. You want to stock up new product to optimize supply chain. You want to understand the seasonal patterns of the visitors. You want to price a vacation rental. You need to have understanding of the location in which the rental is situated to price it appropriately. All these are applications of geospatial data. Now it seems that like obvious that companies should use this data. So we went and found out how companies are using this data. According to research by Forrester, only 26% of the data strategy leaders say that their organizations are using location intelligence to the fullest of its potential. But when you when you ask people, they want to use geospatial data, or they think that geospatial data is important to their strategy. So what is stopping them? Let's understand some of the challenges involved in leveraging geospatial data for business decision making. So let me walk through a couple of examples here. The first one is site selection. Let's say you're Starbucks and you want to identify where to put up your new store. Why is this decision important? A, uh, a good decision will increase your return on investment, and a bad decision in this case will cause you to lose revenue, increase your operating expenses, and potentially lose your market share. Now, to make an informed decision, what are the different kinds of data sets needed to solve the site selection problem? First, you want to understand the neighborhoods, the popular neighborhoods within a city or within a county on where you want to put up this place. And with the neighborhoods, you want to understand where are the places where people are spending time within that neighborhood. What is the demographic of the people visiting those places? Are there any big malls or very dense locations, buildings where there is a concentration of places? Or what are the different places of the same category that exist within that neighborhood? All this information is important to make a decision about the sites, about picking a store. Now, if I now let's talk through another example, which is lead generation, which about like where do you want to stock up your product to optimize your supply chain, and why is this important? If you make a bad decision, your operating expenses will grow because your product is not selling, or if you or you will lose revenue because you are not stocking it up in the appropriate places where there is demand. To make a right decision, you need to understand you need to understand historical sales data, but you also want to understand like what is the temporal information around events, like are there concerts going on, and do those concerts or games uh, attract a specific kind of clientele? What are the seasonal visitation patterns across all these in the stores, in the locations where the stores you are targeting are situated in? To make these decisions now, what you need to have here is like you need to join all these, you need to first source all these data sets, join them, and also maintain historical snapshots so that you can go back in time to understand whether there were any seasonal patterns that will impact your decision. So to summarize this, um, insights from geospatial data are typically derived from joining multiple geospatial data sets. And these data sets are typically sourced from disparate vendors. So you need to work with different vendors to get all these data sets. And then once, even if you have sourced that, like there is a lot of specialized expertise, like you need to bring in special tools like PostGIS or expert personnel to maintain these data sets and merge them in a way that it is usable. Then the next thing is like, because you have to maintain historical snapshots of all these data to go back in time and understand, to do as of analysis, this quickly leads to increased costs. So the amount of upfront investment the companies have to put up to derive value from geospatial data is only growing, is very high. And that's what is precluding them for including geospatial data as part of their strategy, even though the value is going to be very high. So, seizing upon this, recognizing these challenges, we identified and seized this opportunity to build a first of its kind geospatial knowledge graph uh, with the objective of bringing down the time to value for our customers. And let me talk a bit about what is a knowledge graph. A knowledge graph is a semantic network of real world entities and their relationships represented as a graph. The graph structure lends itself to both for humans and machines to understand quickly and easily understand what the data actually means and how the entities relate to one another. Prominent examples of knowledge graph in the 2010s are Facebook's social graph and LinkedIn's economic graph. One of the things that we have done differently is that instead of organizing all our data around individuals, which was the norm in these knowledge graphs that I've talked about, we are organizing all our information around spatial units, whether it is history cells, neighborhoods, places. All the information is aggregated around spatial units. And we added a temporal dimension to it so that you can ask question as of a certain date. For instance, you can ask questions around um, where are people working in this neighborhood going to lunch for? That's a more nuanced insight than some 5-star Yelp rating. Or you want to understand, hey, what are the new restaurants people started visiting just in the last month? So that will give you an idea of popular restaurants cropping up or new restaurants cropping up. So these are the kinds of questions this knowledge graph is intended to answer. Now, the concept itself is not quite new. So why do we think Foursquare is uniquely positioned to build this knowledge graph? I think there are two reasons. One, we believe that we have two foundational assets, which are like the storage and compute of the infrastructure world. So places and moments are storage and compute of the geospatial domain. Any geospatial analysis starts with an understanding of the places in the real world and how people are moving in the real world. And when we started with the knowledge graph, we have spent significant amount of time investing in making these foundational assets differentiated. And take a moment to explain why these are differentiated from other providers or other vendors in the market. First of all, places data, if you look at the places data, places architecture, or how various software vendors aggregate places. You take a lot of digital sources, crawls, trusted data providers, and then cluster them, and then apply your secret sauce to identify which is the authoritative representation of the place. And the problem with this approach is, like, you live in a digital bubble. Whatever is in the digital world is represented in those places. Foursquare, if we go back to the roots, built a places database from a crowdsourcing model, where various users contributed to real world users contributed to the places database. And we have made investments to leverage the strength of ours to make our places data more current. So we are the only provider who does human validation of places at scale. We have a network of super users who constantly curate our data and make it current. So that is how our places data is very differentiated. Now, coming to the movement data, how do you identify movements? You have a GPS coordinate and you want to understand whether the user is at a specific place or not. One of the common misconceptions is that, um, or less understood thing is that the GPS signal, or the GPS or the mobile phone, does not see the world in the same way as humans do. That means you might find this when you go to a restaurant and you see the GPS location. Sometimes it might show you that, like, you're on the other side of the road. Foursquare built its movement detection or visit detection technology based on check-ins. Check-ins are when people explicitly confirm they are at a place. So we use all the signals to determine and build our models to determine where the user is. So even though the GPS coordinate may show you on this other side of the road, we use different heuristics like time of the day, categories, and category of places, and appropriately snap to a place. This is where Foursquare data does very well, even in dense locations like malls or airports, where you cannot just simply draw a geofence or bake some error into a point in polygon lookup to make the movement to detect the visit. Now, we have these assets, but we found that our customers are still spending a lot of time to derive value from these assets. The problem That's when we went a step ahead, a step further with the knowledge graph. We brought in various other foundational assets that are available either in open community or other sources, and connected them to our foundational assets like places. And one of the challenge you will see in location data is that there is no join key, and that's where um, our emphasis around H3 was very important. We were able to connect a lot of location data sets to H3, but H3 itself is not enough, because there is a lot of data about there is a lot of data that is tied to places. For instance, transactions or concerts and events. These are kinds of data sets that can only be attached to a place. So that's why having this foundational asset of a place is important. Now, by connecting all of these things in different ways, we can answer interesting questions. So that's how the idea of the graph evolved. So what we have done is also broke down a vertical silos around our products and built a common backbone in the form of the graph. So all these data sets contribute data into the graph, and then we can now any team in the company operating on this requiring this information can access data from this common backbone. If anyone has worked in big data lakes, you know how difficult it is to discover data. You have thousands of data sets being generated every day, and it is often difficult to find what data is and how do you version it and all that. By identifying our core data sets, we were able to solve that problem of discovery, but also enforce good schema design practices into this methodology. Now, what were the insights we gained? So one is, like, with this particular approach, we can reveal hidden insights much quickly. We have faster access to data, which we can use to improve our own products. And then, more importantly, this was privacy. We took a privacy first approach in building this knowledge graph. And let me walk you through with a few examples. So, this is a visual of the busiest intersections in Los Angeles. And as you see, the redness represents the busyness of that intersection, and it changes throughout the day, right? And how, let me walk through how we arrived at this thing. So one is like we start with the roads network. We identified intersections as anything that has two roads going through it. And then we took a 50-meter radius around to determine busyness of an intersection, because we don't have traffic data. And traffic data may not be a good signal for busyness uh, in some settings, or not actionable. So we took a 50-meter radius to identify all the POIs in that location around that intersection, computed the visits to that particular POIs, and based on that we sorted the top places. And now the color is algorithmically generated. So we indexed all the intersections to hex cells. So this is using our hex style technology. And now you have a view of all these intersections which are busy at different times of the day. Now you can imagine how this could be useful, right? For instance, if I'm a ride hail company, I can use this information to do demand prediction, right? Uh, and then the other use case is like if you're a digital billboard and you are putting this at a location, you're selling ads on to be put up on the digital billboard at this locations. You can optimize, you can price your ads based on the busyness at different times of the day. And this is a very key input, because you'll get more eyeballs at different times of the day based on this information. Now, if you're a data scientist, you can use because this information, the busyness as a score, is mapped to a hex cell. Now, if you have like a location, whatever is your granularity, you can compute, you can factor in busyness as a feature into your score if you're doing some prediction models based on that. Like for instance, in the ride hail case, if you're building a demand prediction model, you can use this as an input. Similarly, uh, I'm also going to use this example to explain how it is improving our own products. So when this is a visual where we have identified, you've used a join between buildings and POIs to identify malls. Malls being any building that has more than 10 POIs. And we were able to quickly identify the top malls in the city, what POIs exist on them. Even simpler things like, hey, making sure the address of all the POIs mapping to the same building is the same, improves our data quality. The other thing it will allow us to do is like we have models to detect drop off points for a POI. And when you know the multiple POIs are part of the same building, you can use that information to accurately predict where the drop off point is for those POIs. So it helps in improving the data quality of our places product, but that's just one example. Now, the third, the key one, which I've touched on before, in the past, all the knowledge graphs were centered around individual as the primary entity, and in our case, we are centering it around location or spatial units like history or neighborhoods or places. What this allows us to do is preserve users' individual data while using it for aggregate patterns to drive value for a lot of business use cases. For instance, you want to target people in the advertising world. If you want to target people in the 35 to 40-year-old age group and are outdoor enthusiasts, today the way to do that is you find the individuals you correspond that meet that criteria and do explicit targeting. The way we are pivoting that is, instead of finding the individual people, we return places where these people are likely to be found at what time of the day. That way, the ad targeting works well without impinging on the privacy of the individual users. So with that, I wanted to summarize or conclude this presentation. We believe a graph and geospatial is the future. Uh, because it helps us connect our data sets in so many ways to really to reveal hidden insights. And these insights can be modeled. Our usage of H3 allows these insights to be mapped to scores that can be used to train different models. Access graph as the backbone for our products accelerates a lot of innovation within the company. And then third, and the most important one, is it demonstrates our commitment to privacy. With that, I'll conclude my presentation, and thank you, everyone.